Hello everyone, I'm Shankha Subra Sanyal and I welcome you all on behalf of S-Cube's classes. Well, I'm really thankful to all of you for your overwhelming response. The amount of love that you have shown through your mails, through your feedbacks, I'm really grateful. I'm really privileged. Hello everyone. Today we are going to talk about electricity. What is electricity? If we look around, this is one of the most important invention of mankind. Now, why do I say that? If we look around, electricity is something which is very important for for appliances that is there in your homes. It is also important for industries. Not only industries, but it is also important for transportation. The trains that run on electricity, right? So I justify my stand when I say that is one of the most important inventions of mankind. To understand electricity, we first need to understand charges. What are charges? Let's take an example. If we have a comb, the same comb that we use for combing our hair, if we have a comb and bring it near small pieces of paper, it would hardly be affecting it. But the same comb, if we rub on our hair and bring near small pieces of uh, paper, you would find that they get attracted to this comb. And why does that happen? That happens because there is a force of attraction that is built up between the comb and the pieces of paper. That's where we bring in something which is known as the positive and the negative charges. A similar example could be when a silk cloth, on a silk cloth, if we rub a glass rod, or maybe a ebonite rod when it is rubbed on some woolen clothes. These all on being rubbed on these clothes or on hair, they acquire charges. One, the positive charge, and the second, the negative charge. Now, what are positive charges and negative charges? If you see, the magnitude of a positive and negative charge happens to be same. The only difference is there is a minus sign in front of a negative charge. The negative charges that we have is bearing a charge of 1.6 into 10 to the power minus 19 coulomb. How much did I say? This is the magnitude of the charge. Now this is the same for both a positive as well as a negative charge. If I need to understand what is a negative charge, let me make this the charge of one electron. Now, if I need to understand how many charged particles is needed to give me 1 coulomb of charge, I would do it this way. Since this is the charge of one electron and we need to find out how many electrons make it 1 coulomb, it would be, if I take it to be n, the number of electrons, then it would be 1 by 1.6 into 10 to the power minus 19. And what do I find? After calculation, we find that this is nothing but 6.25 into 10 to the power 18. That means 6.25 into 10 to the power 18 charged particles is composed of 1 coulomb of charge. If we need to go further, I would say that like charges repel. What is it? The like charges repel while the unlike charges attract. This is the golden rule. Suppose I have a positive charge. Now this positive charge will be attracted. There will be a force of attraction between these two. This is what we call as unlike charges attract. But if we have a positive charge, another positive charge nearby, what would happen? They will be basically repelling each other, right? But again, the same thing would be happening for a negative and a negative charge. If I have two negative charges, what would happen? These two will be repelling from each other. While in the case of unlike charges, they will be basically getting attracted to each other. I hope till this point it is clear. I would like to discuss with you something further than these charges. There are certain things which are known as insulators and some which are known as conductors. What are insulators? Insulators are those substances which do not allow the current to flow through them. I repeat, insulators are those which do not allow the current to flow through them because they do not have free electrons. Like example could be wood, example could be plastic, right? Most non-metals are insulators. But when we are talking about conductors are those which allow current to pass through them. Now, if the current is allowed to pass through them, why does it actually happen? It is because of the presence of the free electrons. If we think about the structure of an atom, we would find that in the nucleus there are neutrons and protons, and the electrons move around in the outermost orbit. Now what would happen? These electrons which are in the outermost orbit, they are free to move, and because they are free to move, they actually are the ones who conduct electricity. Thus, a conductor conducts electricity. It allows current to flow through them, while an insulator does not allow the current to flow through them. What could be examples of conductors? The examples of conductors could be, yes, the metals. Metals are the best examples, like silver, like you have gold, you have copper, you have aluminium. The wirings of your house are all made up of metals, right? Another example of conductors could be the alloys like manganese, constantan, nichrome. The heating appliances are made. Of course, they are not as good as a metal, but yes, they do conduct electricity. In fact, there is a example of a non-metal like carbon. One of the allotropes of carbon is graphite. Graphite is also it also conducts electricity. So what we actually trying to say over here is something which conducts electricity is a conductor. Something which do not allow electricity to pass through them is an insulator. Basically, current or electricity as we call it is of two types. What are the two types? We have one is known as static electricity. One is known as the static electricity, and the other one is known as the current electricity. Now, if you check around, what happens is the example that I have just cited when I said that if you rub a glass rod on a silk cloth, or maybe a ebonite rod on a woolen cloth, those are the examples where the charges are not moving. Since the charges are not moving, they are static. But what is current electricity? Current electricity is dealing with that part where the charges are in motion. When the charges are in motion, that qualifies as current electricity. So this brings us to the end of the lecture. Well, before I sign off, as I always do, I would request you, in case you have any queries, please do feel free to write to me at scubesclasses@gmail.com, or you can WhatsApp me on the numbers given on your screen. It would be a privilege on my part to be addressing your queries. Thank you so much.